Hey guys, Mr. Milton here. Today we're going to look at compound inequalities, number 2. At the end of this video, you should be able to solve and graph OR inequalities. So last lesson we talked about the first type of compound inequalities, the AND inequalities, and today we'll talk about the second type, OR. Okay, so jumping straight into it, find a number that is greater than 10 or less than 3. So greater than 10, if I said a number greater than 10. If I wrote the inequality number 2, a number less than 3. If I put them together, here's how we'd say it. N is less than 3 or greater than 10. Okay. Notice there's no special way of writing these inequalities. So with the AND inequalities, we kind of put them together where it looks like, 3 things written instead of 4. So there's 2 separate inequalities. We wrote one kind of conjoined one. Here, you just have the word or only have the word or in between in your answer with this type of compound inequality. Okay, a solution to this type of inequality, compound inequality, is a number that makes either inequality true. Okay, so it's not both. There's no way that you can be less than 3 and greater than 10. So in the above example, there are infinitely many solutions, or infinitely, I'll say many, let's just say many. There are many numbers that work for both inequalities, okay? But there are an infinitely many solutions, an infinite number of solutions to each inequality by itself. Okay, to show all the solutions, we need to graph. Okay, and our graph will look different than our AND inequalities in the sense that, well, we have 2 different directions that they're going. Okay, if we look at this, N is less than 3, open circle, going this way. N is greater than 10, open circle, going this way. Here's our OR inequality. Okay, so should be very easy visually to see the difference between an OR inequality and an AND inequality. All right, so here goes. It says solve the compound inequality, then show all the solutions. To solve these, simply solve each inequality and then combine the answers with the word OR. Okay, so as we solve this left side, I'm going to subtract 3 from both sides. I get 4x is less than -8. Divide by 4, get x is less than -2. On this right side, I'm going to subtract 7 from both sides. I get -2x is less than -6. Divide by -2. When I divide, I have to flip that sign, +3. So, or x is greater than 3. So as I graph this then, -2, +3, open circle here, greater than 3, going to the right. Open circle here, less than -2, going to the left. Okay, some more examples here. And again, we're just solving these individually and just adding the word OR and graphing them on the same plane or on the same line. So for this left one, I'm going to add 2 to both sides. I get 6 is greater than or equal to 3x, divide by 3. And I get 2 is greater than or equal to x. As I write this down, I want to make sure that I write x first. X is less than or equal to 2. Or, and then I go to my next one. So I'm going to multiply both sides by 4 first. So I get 5x plus 2 is greater than 32. Subtract 2 from both sides. 5x is greater than 30. Divide both sides by 5. X is greater than 6. Okay. So when I graph this then, I have greater than 6, open circle, going to the right. Less than or equal to 2, closed circle, going to the left. And there we have it. You obviously don't need to use 2 different colors. I just wanted to show you what's happening a little bit more clearly. Okay. On the left side, we have 4 times the quantity x minus 1 is greater than 5x plus 2. I'd really love to divide by 4 right away, but I can't because I have to distribute it to the variable. So I have 4x minus 4 is greater than 5x plus 2. I'm going to subtract 4x from both sides and get negative 4 is greater than x plus 2. Subtract 2 from both sides and get x is less than negative 6. I'll write that this way. Or okay, I'm going to subtract 9 from both sides here. So negative 9 is greater than negative 3x. Divide both sides by negative 3. And so I get positive 3 here. I flip my sign because I divided by a negative number, x. So, or x is greater than 3. So here's 3, open circle, going to the right. Come on. And here is negative 6. Oops, messed that up. I gotta make sure that's smaller than what it is. Open circle, going to the left. Okay, last one here, I believe. Nope, last two. Okay, number 3. Notice that number 3 is an AND inequality. Okay, so we're solving this like AND inequalities like we just talked about last lesson. So I'm going to add 1 to every side and get 2x is greater than or equal to, okay, so 32. So now I have 2x is greater than negative 8 and less than or equal to 32. Divide by 2 on every side. And so I have negative 4 right on every side. Negative 4 is less than x, which is less than or equal to 16. So as I graph this, it's an AND inequality. I have a closed circle here. I have an open circle here. Everything in the middle is shaded. Greater than negative 4, less than or equal to 16. And then the final problem, we've got 2/3 times 3x plus 12 is less than or equal to 8. Solve that. I'm going to just start. Let me see, can I do that easily? Yep, I'm just going to start by multiplying and getting rid of this fraction right away. Okay, there's no variable on this side, so I just can get rid of it by multiplying. So on this left side, I'm left with 3x plus 12. On the right side, I have 24 divided by 2, which is 12, right? Because 8 times 3 is 24. 1 times 2 is 2. Okay, so now I'm solving. I'll subtract 12 from both sides. 3x is less than or equal to 0. Divide by 3. X is less than or equal to 0. Okay, number 1 done. Number 2, I have 2/3 x plus 12 is greater than or equal to 22. For this one, I have to subtract 12 first. So I have 2/3 x is greater than or equal to 10. Then I need to get x by itself, so I'm going to multiply by the reciprocal 3/2. All right, those cancel out. X then is greater than or equal to 30/2, which is 15. Okay, and I add the word or in between. So 15 has a closed circle going to the right. And then this one will have at 0 a closed circle going to the left. Okay, so there we have it. We talked about compound inequalities. We did and we've done or. Now, if you can do this, you can do everything in our inequalities chapter. And you should be pretty ready for a test. Look at all that learning. Look at all that learning. See ya.